Most people who think about the Korean War remember, maps with arrows, desperate retreats, and the shock of Chinese intervention. What is rarely discussed is how much of that war was decided not by maneuver, but by materials, specifically by wood that Western soldiers believed was unusable. In the winter of 1950, temperatures dropped so low that metal shattered, lubricants froze, and batteries failed outright. Supply lines collapsed under cold and terrain. And yet, across northern Korea and Manchuria, shelters were built, fires were lit, and entire communities functioned using timber that American and UN forces often dismissed as too wet, too green, or too crude to matter. That difference in assumptions about materials, climate, and survival quietly shaped endurance in one of the coldest campaigns of the 20th century. This is not a story about technological inferiority or rustic improvisation. It is a story about environmental knowledge, building traditions, and why northern builders never feared wet wood. The Korean War exposed how modern armies underestimated climate as a strategic force. By late 1950, UN forces advancing north believed the war was nearly over. What they were not prepared for was the full northern winter. Temperatures routinely fell below -30 degrees Celsius. Fuel gels thickened. Vehicle engines seized overnight. Small arms malfunctioned. More importantly, shelter became a matter of survival rather than comfort. American and Allied forces relied heavily on standardized tents, prefabricated structures, and fuel-dependent heating systems. These worked adequately in temperate conditions but failed catastrophically when fuel could not be delivered or ignited. Wet ground, frozen soil, and snowpack made construction slow and inefficient. Firewood, when available, was often green. Western field manuals warned against using wet wood, emphasizing its inefficiency, smoke, and difficulty to ignite. Local populations and northern-aligned forces operated under a very different set of assumptions. Northern building traditions treated green wood as a normal, expected material. In northern Korea, Manchuria, and Siberia, builders did not wait for wood to season before using it. Green timber was cut, shaped, and incorporated immediately. The reason was simple. Waiting months for drying was a luxury climates did not allow. Structures were designed around the reality that wood would shrink, crack, and smoke as it dried in place. Traditional Korean ondel heating systems exemplified this logic. These underfloor heating systems used long flues that carried smoke and heat beneath stone floors before exiting through chimneys. They were specifically tolerant of damp fuel. Smoke was not a defect, it was part of the system. Heat transfer mattered more than clean combustion. Northern builders understood that wet wood burns differently, not impossibly. It requires sustained heat, controlled airflow, and enclosed spaces that retain warmth. These principles were embedded in architecture, not written manuals. Western forces brought engineering solutions that assumed supply stability rather than environmental adaptation. UN forces relied on kerosene heaters, gasoline stoves, and electrical generators. All required fuel delivery. When roads froze, bridges collapsed, or convoys were ambushed, heating stopped. Improvised shelters were often poorly insulated, prioritizing speed over thermal efficiency. Fires, when lit, were open and inefficient, designed for dry wood and fast ignition. Reports from the winter campaigns show repeated references to inadequate heating and cold-related casualties, including frostbite, trenchfoot, and hypothermia. These were not simply medical issues. They were logistical failures rooted in material assumptions. In contrast, Chinese and North Korean forces frequently constructed dugouts, hillside shelters, and semi-subterranean structures using timber cut on site. Wet logs were stacked thickly, earth packed for insulation, and slowly dried by constant low fires. These shelters were labor-intensive but fuel-efficient and resilient. The fear of wet wood reflected a broader discomfort with low-tech endurance strategies. American military culture in the mid-20th century emphasized mechanization, standardization, and speed. Materials were expected to perform predictably. Wet wood did not fit this model. It smoked, warped, and required constant attention. Using it effectively demanded time, patience, and local knowledge. Northern forces, many of whom came from rural or semi-rural backgrounds, possessed that knowledge. They understood that green wood produces more smoke initially, but retains heat longer once established. They knew how to layer fuels, how to control draft with earth and stone, and how to use structures themselves as thermal systems. This difference was not about intelligence or bravery, It was about what each side considered normal. Cold weather survival during the war quietly influenced later military doctrine. The Korean War forced Western militaries to rethink cold weather operations. The United States Army's later emphasis on Arctic training, insulated shelters, layered clothing systems, and alternative heating methods grew directly from lessons learned in Korea. Manuals began to acknowledge the use of locally available materials and non-standard fuels. However, even these revisions often framed such practices as emergency measures rather than core competencies. The assumption remained that industrial supply chains would function most of the time. Northern doctrines moved in the opposite direction. Chinese and Soviet cold weather manuals emphasized decentralized shelter construction, minimal fuel reliance, and adaptability to variable materials. Wetwood was treated as expected, not problematic. Wetwood mattered because it shaped how long forces could remain in place. Endurance, not firepower, often determines outcomes in extreme environments. Units that could remain concealed, warm and supplied, even minimally, held terrain longer. In Korea's mountainous north, the ability to build and heat shelters without fuel convoys allowed forces to disperse, regroup and wait. Western units frequently rotated out of exposed positions because holding them became physically unsustainable. This had tactical consequences, influencing patrol patterns, defensive depth, and the feasibility of prolonged static positions. Shelter quality became a force multiplier, even if it rarely appeared in after-action reports. The overlooked lesson is not about copying techniques, but about respecting environmental knowledge. Northern builders did not use wet wood because they lacked alternatives. They used it because their systems were designed around it. Western forces did not fail because they were careless, but because their systems assumed conditions that did not exist. This distinction matters beyond Korea. Modern militaries still struggle when infrastructure-dependent solutions meet environments that resist standardization. From high mountains to dense jungles, the same tension appears: technology versus local adaptation. For survivalists and preparedness-minded civilians, the lesson is equally relevant. Materials deemed inefficient or undesirable in ideal conditions may be entirely viable when systems are designed holistically. Wet wood burns when structures retain heat, airflow is controlled, and expectations are adjusted. The Korean War reminds us that materials are never neutral. Every material carries assumptions about climate, labor, time, and risk. Wet wood terrified some soldiers, not because it could not burn, but because it challenged an entire framework of how shelter and heat were supposed to work. Northern builders never feared it because they had already accepted uncertainty as part of construction. Their buildings were not precise instruments, they were adaptive systems. Understanding this difference does not romanticize hardship. It clarifies why some forces endured where others struggled, and why environmental literacy remains as important as weaponry. Remembering these quieter lessons of the Korean War matters because future conflicts and future crises will not always occur under controlled conditions. The ability to adapt materials, rethink assumptions, and respect long-standing environmental knowledge may once again determine who endures and who does not. If you value careful, in-depth historical analysis that looks beyond battles and headlines, consider subscribing to Thermal Vault. And if this exploration added something to your understanding, share it with others who believe history still has practical lessons worth learning.